11.8 Power series. A power series is a series of the form the sum from n equals 0 to infinity of c sub n times x sub n equals c sub naught plus c sub 1 times x plus c sub 2 times x squared plus c sub 3 x cubed plus ellipses, where x is the variable and the c sub n's are constants called the coefficients of the series. For each fixed x, the series in equation 1, which we just read, is a series of constants that we can test for convergence or divergence. A power series may converge for some values of x and diverge for other values of x. The sum of the series is a function. F of x equals c sub naught plus c sub 1x plus c sub 2x squared plus ellipsis plus c sub n times x to the power n plus ellipsis, whose domain is the set of all x for which the series converges. Notice that f resembles a polynomial. The only difference is that f has infinitely many terms. Sidebar: trigonometric series. A power series is a series in which each term is a power function. A trigonometric series, the sum from n equals 0 to infinity of open a sub n cosine n x plus b sub n sine n x closed, is a series whose terms are trigonometric functions. This type of series is discussed on the website stewartcalculus.com. Click additional topics and then on Fourier series. Returning to the text. For instance, if we take c sub n equals 1 for all n, the power series becomes the geometric series. Equation 2, the sum from n equals 0 to infinity of x sub n, of x to the power n, equals 1 plus x squared plus ellipsis plus x to the power n, which converges when x is greater than -1 but less than 1, and diverges when the absolute value of x is greater than or equal to 1. See equation 11.2.5. In fact, if we put x equals 1/2 in the geometric series, equation 2, we get the convergent series. The sum from n equals 0 to infinity of open 1/2 closed to the power n equals 1 plus 1/2 plus 1 over 1/4 plus 1 over 1/8 plus 1 over 16th plus ellipsis. But if we put x equals 2 in equation 2, we get the divergent series, the sum of n equals 0 to infinity of 2 to the power n equals 1 plus 2 plus 4 plus 8 plus 16 plus ellipsis. More generally, a series of the form, equation 3, the sum from n equals 0 to infinity of c sub n open x minus a closed to the power n equals c sub naught plus c sub 1 open x minus a closed plus c sub 2 open x minus a closed squared plus ellipsis is called a power series in open x minus a closed, or a power series centered at a, or a power series about a. Notice that in writing out the term corresponding to n equals 0 in equations 1 and 3, we have adopted the convention that open x minus a closed to the power 0 equals 1 even when x equals a. Notice also that when x equals a, all of the terms are 0 for n is greater than or equal to 1, and so the power series equation 3 always converges when x equals a.